The beginning of any scan-to-CAD workflow, of course, starts with creating and processing scan data. The Geomagic for SolidWorks plugin has an excellent set of tools for processing different kinds of scan data into the mesh foundation needed for a successful reverse engineering project. It is worth noting that while not in the scope of this video, the Geomagic plugin even supports this workflow one step earlier in the process, with the ability to scan directly into the software using many industry-standard scanning devices. The first step of the process is manual scan editing and cleanup. Here are 2 point cloud-based scans that need to be cleaned and then merged. Through the use of different scan data selection tools, such as the polyline, lasso, or paintbrush functions, the table geometry on these scans can quickly be removed. The select through and inverse selection tools are very handy as well when dealing with removing unwanted fixturing or table geometry collected during scan acquisition. Once the data is manually cleaned, the next operation needed for these point clouds is merging. Here, a manual point pairing pre-alignment is used to set things up for a more robust surface best fit algorithm. This gets the scan data into a single triangular mesh model as opposed to the 2 separate point cloud models initially imported. Now that the file is in a mesh format, the focus can be shifted to broader tools with the capability of optimizing the entire dataset on a global scale. Note that some of these tools are actually available at the point cloud stage as well. It's just application or preference which determines if and when they are utilized. The repair tool will diagnose issues across the entire mesh and fix them automatically, such as triangles with self-intersections, holes, spikes, etc. If the automatic repair wasn't sufficient for certain issues, there are manual tools that can perform many of the same functions with the added benefit of increased visibility and control over mesh edits. The remove spikes, detach triangles, and fill holes commands are great options for issues too severe for the automated repair function's filters to allow. For instance, there are several large holes still present in the mesh. Through the hole filling tool, the patching of each hole can be controlled individually to ensure a good quality result. The remesh tool is useful for remapping the entire mesh with cleaner, more uniform triangles. This is a best practice to improve a model's performance down the line, especially with tools like smoothing or auto surface functions. The smoothing function is fairly self-explanatory. By running a remesh function before smoothing, the smoothing tool has been given a clean, evenly triangulated mesh of smoothing control points. Smoothing meshes with high-density, evenly spaced triangles tend to get much more desirable results than meshes like the previous one with scanning artifacts and triangle inconsistencies. The Simplify tool is a final file size optimization tool to be used once all other mesh editing is done. Up until this point, the model has been edited at maximum detail to ensure no small features that might be critical are lost. Now that those edits are finished, keeping the file at a maximum detail creates no extra value and is actually detrimental to performance on many downstream functions. Through the Simplify tool, areas of low curvature are consolidated into larger triangles, while the details in areas of higher curvature are maintained at higher resolution by keeping triangle size smaller. This creates a functionally identical surface to work with while using significantly less data to represent it. Although maybe not the most fun or interesting part of the reverse engineering process, ensuring your scan data is clean and optimized through the tools available in the Geomagic for SolidWorks plugin sets a rock-solid foundation for success throughout the remainder of your reverse engineering workflows.